Steve Holland, here with the DEC. Thank you all for coming today. We have a great presentation with Ken in Natural Stone Facades, but first, I want to hand it over to Greta, who'll be talking about the WAGI Symposium. And I also want to get Facades Plus on everyone's calendars. That's July 12th. That'll be another great event. But let's hear from Greta and the call for abstracts. Greta, the floor is yours.
Okay, thanks, Steve. Yeah, I'm very happy to announce that we are already working on a symposium for this fall, the 4th WAGI Symposium, and it will be held on the 26th of October. So put that on your calendars now, and we hope we can see as many people as possible from all the different disciplines involved in the building enclosure. We've issued a call for abstracts, which I am going to put a link in the chat so that you can go right to the BSA webpage where you can learn more about the call for abstracts. The theme for this year is building enclosures that last. And this is kind of, the idea came a little bit from a publication the AIA put together a few years ago called Buildings That Last. And we all think of durability when we think of something that lasts. But another aspect that will make a building enclosure last is its adaptability, its maintainability. Can elements of the facade be reused or recycled? And really, how does it fit into the big picture of sustainable design? So we encourage everybody to think of different ways that your design of building enclosures or your construction or the materials you represent contribute to its lasting quality. So I'll just put that in the chat and hand it back over to Steve. Looking forward to Ken's presentation on a material that really does last, stone.
Right, you are, Greta. We're all really excited for the symposium. But I'd like to introduce Ken Lambert. Ken is one of the BEC's very own board members, and he is one of the directors at IMI, but I'll let Ken take it from here. Thanks, Ken.
All right, thank you, Steve. Thanks everyone for coming here, showing up in person, and then I know we have some people online, so appreciate you checking in tonight. Before we get going with this, I'm going to just hand out, I have two things I'm going to hand out. One, and you can just pass it around, nothing too exciting, but Indiana Limestone Handbook. This here is like one of the Bibles that we talk about when we talk about stone. So there's a few others. There's actually a big one. It's about this thick from the Natural Stone Institute, which I didn't bring because I can't lift it really all the way from the parking garage to here. So take a look at that. I actually, I tabbed this page, which has to do with mechanical attachment and an anchor guide. So this is just one page. Again, this is the kind of thing that we'll talk a little bit about that, but also in that document is pretty good. And then also care of Structural Stone, which is out of Rhode Island, not too far from here. There's a few samples of some stone and some finishes that of some popular finishes for exterior facades. So we have a thermal finish, we have a honed finish, and a couple different types of granite. Structural Stone down in Rhode Island, mainly granite fabricator, large granite fabricator. There you go. So there you go. And we have someone from Structural Stone here, so he's probably gonna he may heckle me later. We're not sure. So anyways, hopefully everyone can hear me all right. Natural stone facades, we're going to talk about attachments and some other considerations. There's a lot about natural stone with exterior facades. We're not gonna be able to get into everything in 50 minutes, or an hour, but we'll do our best. At least it's basic. So I'm Ken Lambert. I'm the IMI director for New England International Masonry Institute. So I'm also very involved in CSI. CSL, anyone from Massachusetts knows what CSL means, I assume. So I've had that for a long time. I used to be a contractor for many years before going to IMI. This is obviously one learning unit. We'll get the list and take care of all that after. So learning objectives tonight, we're going to review the types of stone that are recommended in a freeze-thaw climate. Okay. We're going to learn about the basics of mechanical attachments for dimension stone and also full bed stone. I don't want to forget about full bed stone, even though the walls are getting thinner and thinner, but full bed stone is still out there, still being done. Discuss the requirements and standards for adhered thin stone veneer. We do whole hour presentations and more than that on adhered masonry veneer, which obviously stone is part of the masonry veneer. There's a lot of issues out there, I think, with adhered veneers. And so we'll talk about some of that. I'm not saying, I'm not anti it. It's just, we got to do it. It's got to be done correctly and designed correctly also. But review the benefits of using natural stone as a facade material due to its low embodied carbon and its general durability. I think we all know it's durable. And there's not much that's more natural than stone, right? We're actually pouring it, pulling it out of the earth. There's no manufacturing involved other than obviously, extracting it and then some fabrication. So before I get into those four things, just a few slides on kind of where stone masonry came from and where we are today, just masonry in general, really. I just do this as a background. I mean, I think most of us know what, masonry's been around forever. We all know this. When were the first reinforced concrete buildings? When were cavity walls started? Transitional walls, of course. When was the first engineered masonry code? Not to 1966. First movement joint code was actually a state code in Wisconsin, 1974. Then we get into rain screens starting to come in the 80s. We'll talk about rain screens in this presentation. US air barrier in 2001, and then software for masonry as far as whole building analysis started around 2009. With all that said, back in the day, right, I think everyone knows this building or is quite aware of it, late 1800s, a combination mass masonry and transitional, steel frame building. At the base of this building, as I think we all know, it's 5 foot to 6 foot thick walls at the base of the Monadnock building, right? Nowadays, we don't really build like that, but that's again, how masonry began really. And this, I think many people have seen this also. It's from a chart from various sources. There's Boston, is an 8-story Boston warehouse at the first floor. This is for unreinforced masonry, right? So you're gonna have 28 inches thick. Second floor, 24 inches thick of unreinforced masonry, brick or stone, of course, back then. CMUs didn't come into play until around the 1920s or so, 1930s, when they started getting popular. So as far as we're concerned here, we're talking brick or stone. Again, and then the transitional kind of hybrid buildings and facades in the 20th century, kind of late 1800s to the mid 20th century. This was, kind of what's all around us, I think, in Boston here. And then today, 70s, 80s, up to today, we have a conventional cavity wall with a stone facade. Again, we're talking about stone, so that's why I have it here. So you have a full bed stone veneer, or you have this dimensional stone veneer, which these are IMI, just quick plug for IMI. The masonry detailing series. If you have never been on our website, go to the website. This is free, it's open access. These are great details. These are pretty simple here, these ones here, but all drawn in SketchUp. And so again, it's reversible, it's zoomable, all call outs there, really good details. And that's really one of the best parts about IMI or our website is those details. So first, we're going to start off with a general exterior stone selection review. We're not going to get into factors of safety, but I'm sure many, the engineers in here know what the factors of safety is. This will not be a geology 101 course here. I missed that class at Hasbrook, so at UMass. So we're not going to get into all the igneous and metamorphic and sedimentary types of stone, even though those are the three classes of stone. We're going to try to be practical here tonight. The most common stone types for exterior facades in a northern climate are granite and limestone. I put porcelain tile up there also. It's not a stone, and I know it's manufactured, but there's a lot of similarities between porcelain tile panels and like I say, a granite panel. But we're not going to get into the weeds with that. But even some of the movement joint locations and other installation requirements, there's a lot of similarities between those two. So stone types. So that I always like to know, what shouldn't you do? It's good to know what you should do, but what is not a good idea. So stone types not recommended for exterior facades. Engineered stone, meaning like a quartz or Caesar stone. Natural quartz is okay and applicable in many circumstances, but I'm worried about these, engineered stone, which are manufactured. It's a stone-like product, which uses resins, right? And it's very popular in countertops, right? Interior countertops, right? Most of those use polyester resins to bind everything together. They're like trying to create a stone. They're trying to create granite, basically, or quartz, which needs that resin needs to be shielded from UV rays, obviously not good for a facade. Also marble and onyx, that depends on several factors, including thickness. We'll get into that. You may say that seems weird because obviously for centuries and centuries, we've been building with marble. You see marble everywhere in Rome and Italy and Europe, whatever. And but we'll get into that, in a minute. And then there are also potential concerns with low density tier limestone. Limestone is everywhere, but there are issues with where the limestone is coming from and the testing of the limestone. So we'll get into some of that also. So first, marble and onyx. We don't see a lot of onyx, but as far as marble and onyx, they're similar. They're grouped into 4 classes based on soundness of the stone. So only the top groups, the most sound, should be considered for exterior wall use. That's number 1. Then there's hysteresis. It's inherent with marble. Marble shows small increases in volume, right, with the rise in temperature above the starting point. This can result in differential expansion within the stone. Hysteresis is more likely to be accommodated or restrained in a thick veneer more than a thin one. So I think you probably all heard of, right, there's a big project, that building, I think it's in Chicago, right, that had many issues because of this. It was a 20, 30-story building, and they used marble as a dimension stone, and it was only, let's say, 2 inches or 1.75 inch thick marble, and many problems with that. Basically, multi-million-dollar lawsuit and all that all had to come down. So we don't want to do that. In the past, marble, what you see out there, it was marble building stone that was literally like 12 inches thick. Okay, so it could, with building blocks, basically made out of marble, that can restrain some of those issues. So, but we're not really building like that now. So, that's the point of being a little skeptical of marble today. This is a chart that I put together when I was bored on a weekend. Comparison of typical exterior facade stone types. I felt like this needed to be done, but maybe not. I'm not going to get into all these numbers, but if anyone wants this chart, you can email me after. But it's just looking at what are some of the important things for an exterior facade, for an exterior wall. We're looking at, compressive strength. We're looking at flexural strength. Again, modulus of elasticity. The key things really, I think, density is key. Absorption percentage is key. And then I threw down abrasion resistance and the Mohs scale, right? The hardness scale. And I just, use this as a comparison. What does it show? I think that it shows that granite is usually a great choice for an exterior stone facade. You look, it's not very absorptive, which is good. All right, that's what we want. It's very strong. It's very hard. And obviously it's beautiful. And there's all kinds of different granite quarries and granite veins and things like that. And you can see that limestone is much more absorptive. And look at the variance between, again, that kind of base level limestone and the higher density limestone. It's a big difference. You don't want this. You don't want that as an exterior facade. So you have to kind of watch that. You can't just blanket say limestone is the way to go. I put slate on here. Actually, there's a library in Massachusetts, not too far from here, built out of 6-inch full bed slate. It's very cool, and it's actually was just built like 3 years ago. So I was out there about a year or two ago. So again, things are done that maybe you don't think that they're still done. Yes.
Great question. I just want to understand some of the reservations about marble. So, like, let's say you had a opportunity to do 1.25, 1.5 inch thick marble. Is it about the marble itself? Is it about the method of attachment? Like, my understanding is like a pin anchor is more appropriate than a kerf anchor at that thickness. Is it just to be sort of discouraged in general, or is it more about the particular stone? Like, how would you navigate that sort of situation?
Yeah, there's a lot of variables on the size of the panel, right? So
It's a small panel.
what do you say?
Small panel, 1 foot by 2 foot.
Okay, yeah, so maybe again, that's gonna make a difference. So, you're gonna, as far as movement and the expansion, if it's smaller panels, you may be able, and right, you could look at the anchorage of that and, be able to accommodate, I think, for some of that. So the one big multi-million-dollar lawsuit, that was kind of the worst of everything over there. And I think it was, again, it was like 1.5 inches, but these are big panels, and it just was that was just one circumstance. So, it's sort of discouraged, but you know, it's not to say it can't be done. If that's a,
Does the stone itself come into question?
Yeah,
Like, is there
well, yeah.
a certain marble that's more suitable than another?
I
Is-
think I'm
is-
add to that.
sure, yes, please.
We have completed the marble project actually 3 years ago.
Okay.
but we went through excessive amounts of testing and the selection process. The main issue is the freeze-thaw and rolling of the marble,
Mhm.
which comes to the density absorption. There's a lot of specific tests that we have to carry out to see whether or not it's suitable material, but we can talk after.
Thank you.
Yeah,
Yes.
good. Just curious if it's like stay away from marble if it's less than 2 inches or if it's more.
Yeah, it's not that hard and fast, I don't think, of a rule. Yes,
In terms of limestone absorption, US based limestone in the mid-range or high range?
US based limestone is everywhere. It's gonna be from the low range to the high range as far as, you know, absorption percentages, it depends. Where it comes
Area
in.
the World that limestone is denser than other, than it's closer to granite or.
Matt,
In Wisconsin, there's a limestone up there that's very, very dense.
okay,
Indiana is a little
a
less.
little less so, yeah.
And then even further up in Canada, Owen Sound area. There's very dense material up there.
Yeah, so there's a lot of variation. Good question.
Slowly though, like the slate, like the densest slate you'll find is in Spain. You can get other slates that are.
Yeah.
that we do.
So unfortunately, right, there's a lot of variety in what we're talking about here. So that's what makes it a little difficult. Notes on limestone for exterior wall use. Again, this is sort of what we're talking about. Limestone sold and specified based on 3 tiers, low, medium, and high density. Again, those low density limestones may not be great for an exterior choice, right? In a freeze-thaw climate, especially, which we are in. That little excerpt is from the Natural Stone Institute on the left. I'm going to mention Laticrete a few times here, and there's a lot of good data here and nice little excerpts. I'm not a rep for Laticrete, but Laticrete has a lot of good information on stone and especially adhered stone. But anyways, Laticrete put this out again, basically saying the same thing I just said, saying that you want a high density limestone for exterior facades. So that's, you know, just from one other source there. What about brownstone? Okay, brownstone is all over the place here, right? For what is brownstone? Brownstone is brown sandstone. Right? It's often with reddish hues. You see it, you know, again, you see it around. Brownstone widely used in the late 1600s to the early 1900s. It was used as a veneer or as the structure, right? The minimum veneer stone depth, about 4 inches. It's a sedimentary rock. It's related to quartz. The similar building characteristics, though, and properties of limestone. And I just wanted to put this down. It's not all about historic, you know, churches and stuff. It's still being done. So it's still being built with new construction with brownstone. Here's a job in Connecticut. I was just there about a year ago. Retail development in Avon, Connecticut. So it's very cool. It's beautiful. Again, you have kind of colored mortar joints. So, you know, you're kind of not blending it fully, but it's not your typical mortar color. Project uses a rock face, 3 5/8 full bed stone, brownstone, and then also in other areas, they were using 1.5 inch adhered brownstone. So it still is done. Now, the brownstone was imported, and you probably know that. This brownstone was imported from, I believe, China or Asia, somewhere in that. There's not a lot of brownstone anymore here that's being quarried, as far as I know, but you can get it. And then this is just sandstone, again, brownstone, sandstone. Sandstone has similar properties to limestone. That's kind of all I wanted to say with that. So now I'm going to get into some attachment details and some of that, and some definitions. Mechanical attachments of dimension and full bed stone. So it's a couple of definitions here. So natural dimension stone sometimes has no mortar, sometimes does have mortar. We'll look at a few pictures. Full bed stone obviously will have mortar, right? ASTM C1528, they define dimension stone as 1 1/4 to 3 inches thick. But if you talk to Matt here from Structural Stone, dimension stone can be 12 inches thick. It could be whatever, right? And so again, that's sort of definitions, whatever, but this is again specific to exterior cladding. That's what they call it. Here's another IMI detail here. This is a very simple, this is just a, not a rain screen type system, obviously CMU backup wall, because we're promoting CMU backup walls. And so there's nothing fancy here. You have a stainless steel Z strap anchor bolting right into the CMU wall. You got an air vapor barrier, obviously, note the shims as required there in blue. We're going to talk about how this can then become a rain screen wall system, right? So it's a lot of these cool rain screen wall systems, and the subframing is a lot of those have adjustability. You can do things with those. But with this, there's no adjustability. You have this size, of an offset, and that's it. And so you have to shim, and again, the installer has to do things to keep things, plumb basically, and level on the wall. Stone attachment to a wood or a like gauge metal frame stud wall. So this is a document from Indiana Limestone, and I get this question all the time, especially with adhered veneers. But anyways, even with this is from Indiana Limestone Institute, which I passed the book around. They are basically saying you want an L/600 or an L/720 wall, backup wall, when you're using stone in general. That's a generality that I hate to say that, but so if you're using soft joints around each stone, or if they're open joints, then you can, I hate to say get away with also, but you could do L/360 or L/480, because again, then you're not as worried about deflection if there's no hard joints, right, around every stone panel or every stone. And again, I have a few pictures here of just, some installations. There's a granite base course there. Here is, one split tail anchor, going into a stud wall, cut into a little kerf there. And again, that is just, that's that other side of that picture with the mortar joint there. Mechanical attachments to stone. There's a picture here of a lot of different kinds of, and we're not going to go through each one of these, but there's a lot of types of a lot of different anchor types, right? And the shapes, there are a lot of different things available. We got dowels, we got pins, we have different, tie wires. Coordinate with the quarry and the supplier, coordinate with the backup wall and the frame. And what's the material type? Are we talking stainless steel? Or are we talking galvanized steel? Okay, that's key. Yes.
You anchor a Nashlar 3-inch limestone veneer with a regular masonry anchor instead of a split anchor.
A regular.
Random ashlar.
Oh yeah, random ashlar.
Yeah.
No, you could. Yeah, we're going to talk about that actually.
Okay.
You don't need one of these specifically.
Okay.
We're going to talk about that in a minute. So material gauge, the dimensions, wire tiebacks. That is sort of an old, fairly historic way of trying to, tying in stone or especially marble. Those are usually copper or stainless steel tie wire. It's generally not recommended for over 15-foot high installations. So again, if you're doing a base course, and we do, people still do it, masons still do it, but it's okay for a couple of courses, but I wouldn't do it 30-foot high wall with tie wire. That's just a recommendation. So this is a typical, again, IMI doesn't promote manufacturers or brands or whatever, but I mean, we do, see Homan and Bernard frequently, right? And most of you are sure familiar with it. This is just a typical, split tail stone anchor. This would be the submittal, right? That you'll probably see, or you'll probably be, having to approve. But, the mason, the supplier, the manufacturer, and the quarry, they can offer, and IMI, I mean, we can offer suggestions on specs and anchorage, but ultimately, of course, it's the project architect, it's the project engineer that has to specify this. And so all these different fill-ins here, how high, what is, do I have to go 1 inch into the stone on the kerf on the, all of this, the gauge, that all has to be determined. And so H&B, they don't really, you can speak to them and they can give you some kind of past history, historical, information, and we can too as well. And there's other guidelines, which are Indiana Limestone Institute, Natural Stone Institute are two big guidelines on that. You can get some of that as far as getting started with specking anchorage. This here is out there. It's ASTM C1528, the standard guide for selection of dimension stone. So this doesn't have anything to do with installation, really. This is all about, you were talking about like, well, should I use the stone? Should I not use the stone? What do I have to be worried about the stone? What testing should I require in the spec for the stone? This is what this ASTM document, right, is all about. There's also another one called C-1242. I put it on the bottom. And that's a guide for dimension stone attachment systems. So that's getting more into the attachment and the installation of the dimension stone. So those documents do exist. So sometimes, yes.
Does that also cover like latitude and sort of multi-bin set, this type of stuff, or is that a completely separate area?
The 1242 does get into adhered stone as well a bit. So it is a good document to have.
And we're gonna talk a little bit more.
We're gonna talk more about the adhered veneer in 1 second. I gotta keep an eye on the clock here, Jimmy, because I know I'm about a half hour. Okay. Limestone sizes, general notes and thicknesses. Again, I hate to say general notes, but I will here. This excerpt is from Indiana Limestone Institute. So dimension stone, also known as building stone, right? It's natural stone or rock that has been selected and finished to specific sizes, trimmed, drilled, cut, ground, etc. Limestone minimum thickness is usually 2 inches at the bare minimum, usually 2 1/4 or even more. At 2 inches thick, the maximum size panel is 36 inches by 60 inches. So this is what Indiana Limestone Institute puts out there as a guideline. It's not to say that you can't push that or stretch it or, but this is the guideline from Indiana Limestone Institute. And Indiana Limestone is all over the country. I mean, it's well known, well respected. We talked about going to a rain screen. So this is, very similar. This here has a little different system. So this here has pins, going up into the stone. You can see that from that, horizontal rail. But, this would be a rain screen type system. And then we're just not showing the rigid insulation or whatnot. But, same kind of idea on newer rain screen installations. This here is a cool system. I don't know if anyone has used this. This is with Gridworks is the back, the subrail system. Okay. So they're making this. And so the stone fabricator is going to have to put a kerf in the top and bottom of each piece of stone. So obviously this is a horizontal, layout, for the stone. But again, this is a rain screen system. We have then vertical rails. And then you even have clips, you have, thermal isolation pads, you got everything there for, thermal bridging and all that. So in the 2023 City of Boston installation, right, you can do this, right? And so there are means of doing a stone facade. And then really the modern open joint rain screen system is an extension of a masonry cavity wall. So masons have been installing stone facades with mechanical anchorage, for decades, for centuries, really. So we'll talk about ashlar veneer a little bit, full bed. So ashlar is just a type of full bed stone. This is just a little picture of it. Typical features, 4-inch nominal depth, maybe up to 6 inches. Wall ties are needed, very similar to like a brick tie or like a brickwork at max I'm not going to read every word here, but it's very similar to a brick veneer installation. Okay. Maximum 32-inch horizontal, max 25-inch vertical for the ties. Type N mortar typically for a veneer, and again, even for ashlar stone. See following pages, we'll look at this is what we're talking about, right? Ashlar veneer. Okay, that's from Best Stoneworks that I borrowed that picture from. I'm not going to go into I'm not going to read everything here, but ashlar specifically, in order to make it look good, you have to follow all these steps. So the masons in the field, they know this, so they have to do this, or else it's going to look foolish. You can't have it look like a step, like you're walking up the wall. There's all kinds of rules here. The stones must be level. All the stones are rectangular. Okay, you don't have any oddball triangles or round shapes or whatever. This is just for ashlar. You can do other types of full bed stone that is not ashlar. But again, I don't want to go too far in with that. What's important with stone masonry is flashing, right? So flashing is something that IMI takes very seriously at all the union masons that we work with, basically in the BAC. We have a 5-page flashing installation checklist, which anyone can email me. Again, I can send this to you. It's a very good guide for in the field. So for the CM, the GC, the masons, or whoever. And we have this whole document that we put a lot of time in. We actually update it every few years. So that is out there. That's useful. We also do a flashing upgrade class for the masons. So we're sort of practicing what we preach as much as we can here with flashing. And then we do foreman training, foreman certifications, just in general. It's nothing to do with stone, but we do a foreman class. It's like 15-hour class that, a journeyman who wants to be a foreman goes through all this. And actually, I'm part of that group at IMI that helps to kind of train the next foremen and foreperson out there. So now we're gonna talk about adhered thin stone veneers, key requirements and standards. Like I said, we get a lot of calls on this all the time. In general, an anchored veneer is the veneer units have to be a minimum of 2 5/8 inch thick. Adhered veneers are usually about 1 inch or 1 1/4 inch thick. They can even be as low as like 3/4 of an inch thick for an adhered veneer. That's the general, that's what's in the TMS. TMS is the Masonry Society, right? So TMS 402-602 is the Masonry code. Those documents are part of and referenced in IBC. So that is the Masonry code, is TMS 402-602. Oh yeah, here we go. Adhered Masonry veneer codes and standards puzzles. We have this slide, which I like because basically it can get complicated with adhered masonry veneers here. What is the proper spec? What's the proper design? So we're looking at IBC, of course, right? We're looking at the Masonry Society's guidelines. We're looking at masonry industry standards and guides, things like the Indiana limestone and things like natural stone. There's all these other guides, Latticrete's manual, which I'll look at in a minute. If a manufacturer has an ICC evaluation service report. So the problem with natural stone is that it's not manufactured, right? So no quarry, because it's not manufactured, there's not going to be a ICC, evaluation services report for the most part, because it's no manufacturer is paying to do that. So this is kind of a general slide for all kinds of products. So as far as we're concerned here, international with adhered masonry veneers, and stone is part of that, obviously. Where is it? Well, you get, section 14, in the IBC talks about exterior walls and what's required with an exterior wall. There is about 1 page or so in 1405.10 talking specifically about adhered masonry veneer, definitions, minimums, requirements, very basic stuff. You wouldn't really build a wall based on what is in IBC for adhered masonry veneer. It's very limited information. So, when we talk about adhered masonry veneer, there's all kinds of things going on. Today, we're talking about stone, but there's all kinds of other, we have thin brick, we have all this other stuff, which we're not going to get into today. Some are natural, some are manufactured. What's the attachment? And then the options on drainage mats and weep vents and insulation. There's a lot of options. That's why we get called on this all the time. So for natural stone, this is a good slide to have. For natural units, this is what is out there, right? So as far as guidance and help for you or, for a designer, obviously the manufacturer, right? That's a given. If there is an ICC evaluation report, which is not going to be in most cases with natural stone. ASTM, we talked about that, C1242. There's a Building Stone Institute, there's a Rocky Mountain Masonry Institute, there's a Natural Stone Veneer International, BIA, that's really for brick, obviously. ANSI does have some information there, especially on mortars and things like that. And then IMI, of course, reach out to us. And then I threw in there the Latticrete. So the Latticrete Direct Adhered Facades Design Manual is right here. And that is probably, I think that's the best manual out there for adhered veneer. They really get into a lot of detail. It's about over 200 pages long. I mean, all kinds of guidelines in there. And again, I do throw out there, when they have their assemblies and their recommendations, they're of course recommending, Latticrete, 22, whatever. And I get that. And, but that is good information. I would look at that maybe if you're looking at an adhered masonry veneer. Yes.
So all the
I'm done.
people that you referenced in terms of standards.
Yeah.
Who kind of has the final say when those
Sorry about that, online.
in terms of what happens at grade?
At grade?
At grade.
Yes, so that's a good question, because at grade, IBC obviously has their minimums, right? And that's, so you gotta go by that. But then the manufacturers obviously are gonna have, I would say, as far as the hierarchy, it's not up to me, but I mean, the IBC, and again, TMS is part of IBC, right? And then I think the manufacturer with natural stone, it's a little different because it's not a manufacturer. But let's say you're doing a manufactured stone, cultured stone or whatever, you have to go with what they say because they're backing up the product.
So let's say a hypothetical real world situation here, where the manufacturer says, yeah, you can put stuff below grade, no problem. And Laticrete says, yeah, you can adhere our stuff,
Yeah.
like right down to grade, no problem. And yet,
Yeah,
that doesn't happen. Why? Because of IMI or other guidelines. That say
right.
don't do that, right? So you have
right.
the material manufacturer saying, this is fine.
Yeah,
You have the, Laticrete saying, this is fine.
right.
And yet there is a uncomfortableness or unwillingness to
Yes,
do this.
Right.
Where does that come from? Like, how do we negotiate that?
So usually what I find is it's the opposite of that. Usually you're gonna have the manufacturer, Laticrete or whoever, saying, we don't want you don't do that because then our mortar's gonna fail or, we're gonna have pop-offs and then we're not gonna warrant. Because then you're gonna come crying to Laticrete or come, crying to whoever, Glengarry, Thin Brick or whoever. And they don't want that. So usually they're more conservative, I think, when you read through all the warranty and all the information. This page is kind of, it's over there now. This page though, it kind of gives a, it shows that it is fairly complicated and that you have to kind of do your due diligence. But IMI is happy to help you do some due diligence. I mean, and when we give recommendations, here we're coming back. All right. IMI gives recommendations and they're just one way of doing things. And again, you can do it other ways and, but yeah, it's
People
tough.
tend not to disagree though, right? So again, like, obviously you don't want to build a rain screen cavity that becomes like.
Right,
So you don't take your rain screen down below grade.
right,
So at some point you have to transition to
Yes.
some sort of an adhered solution, right?
right.
And if the material is okay with that and Laticrete is okay with that, then they both point to.
Maybe I need
a
to
third
move it.
party, IMI or
Yeah.
someone else who says, that's not good practice.
Right,
Well, now all of a sudden I have no feedback. I have no good answer to provide to the design team.
right. No, I get it. I understand. It's,
So I'm kind of trying to figure out how to negotiate that because I haven't been down that path a couple of times.
well, call me next time you're down that path.
I will do.
All right. I can't give a better answer than that, I guess, on that. It is complicated. Yeah, that's, so again, that's my little pitch on the Laticrete manual. You can download it for free. I would do that. This is interesting for adhered veneers. So this here is from that ASTM standard. I'll stand up now. C1242 on dimension stone. This is interesting, and most people don't realize this. So what do they say in the ASTM? They say limit the use of adhered stone veneers to a height of 30 feet. So that doesn't happen, obviously, all the time. We see adhered veneers going freaking 70 feet or, whatever. So this is just an ASTM guideline. That's all. It's a guideline. It's an industry standard. It's an industry guideline. So there's issues with, obviously ASTM created this and they made that recommendation for a reason. They also say to inspect the cladding hands-on approximately 1 year after installation, then at least once every 4 years to verify the system is performing adequately. Does that ever happen? Yeah, well, I don't know what it is, but I don't think I don't see it happening very often. I know we have the facade, ordinance here in Boston, but that's kind of different and that's over 70 feet, right? And every 5. So again, this is just an ASTM. Doesn't mean that you have to follow this. It's just this, think of this when you're designing a building, I think, and then this is an excerpt from Laticrete. Sort of the bottom line on adhered veneers is quality assurance. This is saying is the success of a adhered veneer project depends entirely on good quality assurance and QC program implemented at all levels of the project. Unfortunately, as we all know in this room, probably comprehensive quality assurance programs are often overlooked and not done frequently. So there is no belts and no offense. No. Yeah. There with adhered veneers, don't come after me after. There is no belts and suspenders approach with adhered veneers is sort of the bottom line. So, we get that mechanical attachment, you feel a little better about some things. With adhesion, you're just, was it put on at the correct temperature? And again, you have big panels that are 50 feet up in the air, there can be issues. Here you go. So outcome of improper bedding. So these panels just fell off the building, okay? So hopefully no one was standing right on the side of the building. So ANSI A 108.5, I mentioned ANSI earlier is one of, there's all these different guidelines. They require for an adhered masonry veneer, minimum 95% adhesive mortar coverage. So they require that for a reason. Especially it's true in a freeze-thaw climate. If there are any cracking or any areas where water can get behind there and kind of work its way out, we can get issues like this potentially. So you don't want to take shortcuts, I guess, on adhered veneers is sort of what we're saying. This is another. This is one of those. Here we go. Dry stack adhered veneers, right? This kind of look. For some, I don't personally love this look, but a lot of people really like this look. So this is out there, and I get calls on this all the time is, can we do, or how do we do a dry stack adhered veneer look? Because the client wants that look, right? They don't want to see the mortar joints or whatever. So, according to the Building Stone Institute, there's all these institutes out there, right? Dry stack patterns like this, they're not recommended for exterior use in harsh environments like Colorado, they say, with lots of freeze-thaw cycles. I would say New England also is a harsh environment, similar, maybe not exactly to Colorado, but it's, so again, this is just caution. And IMI, we just are, we're going to give you some best practices on the next page if you really want this look. It also can void some proprietary system warranties. It can void some of the mortar, the setting mortar warranties. So again, look at Laticrete or spec mix or whatever you're using, Quikrete or whatever, make sure that they allow you to do this. Consider using raked mortar joints instead to mimic the dry stack look. So it's you're kind of cheating there a little bit, but at least you got some mortar in between the stone. Use professional judgment and then upgrade architectural details in the setting material. So here's some ideas on that. So, that's just a little mock-up we did, or someone did. Upgrade the water air barrier on the back wall. I think this is key, is providing full height drainage ventilation mat on an adhered veneer. I think that's a good idea. It costs a little bit of money, but again, it's we're talking about this belts and suspenders thing. I think it does help a lot. It's going to drain, it's going to dry out, much better. And so I get calls on this, on the drainage mat thing and adhered veneers frequently, where the full height drainage mat has come a long way, where now it's, I don't want to say it's the standard thing that everyone's doing, but it's quite common now compared to 10 years ago, 10, 12 years ago. No one was doing that really. And they were just, the lick and stick. And that's what everyone says. I hate that phrase, but that's what people were doing. And some of them are still doing, and you have some issues. So the drainage mat, I think, is worth the money. Upgrade metal lath. There's a few things you can do there as far as the weight of the metal lath. Upgrade the setting material to a polymer modified mortar. That is something that could be done. It helps with adhesion. Specify a durable veneer unit, and then you want weep vents at the bottom and at the top. So we say that with any masonry wall, the weeps, everyone knows weeps at the bottom, or weep screed or something at the bottom, but have a means of drying out and ventilation at the top of the wall also. Provide adequate movement joints. So people seem to forget about movement joints. So I would say it's more important on an adhered veneer than on a mechanical veneer. It's the same, it's all important, but it's very important on to have adequate movement joints. And then approved mock-up. IMI is a big fan of approving mock-ups. Here's your, drainage ventilation mat, best practices, refer to the local code requirements. I should know this, but I don't know it, but I cover all New England, so I have to know every state building code, and the amendments, but I don't think in Mass, it's not required. You don't need a full height drainage mat, I don't believe. So there's nothing in the building IBC that says you have to have it. We're just saying it's a good idea to do it. In some states, it's different. So in Wisconsin, in the IRC in Wisconsin, their amendment, you need a full height drainage mat to do an adhered veneer. It prevents inward vapor drive. So when you're buying a mat or speccing a mat, you need 3/16 of an inch minimum gap thickness, okay, for an adhered masonry veneer, okay, to break that, well, some of it is just to break capillary action. In Canada, it is in the code, and you need a 3/8 inch minimum drainage mat, okay. And then as far as maximums, it would be 3/4 of an inch maximum gap, maximum drainage mat thickness Yes.
Does anyone ever speak to actual open area, or is it just the overall thickness?
Well, I'm sure that is part of it, because right, like how is it made and all that, we don't have that slide, but yes, it's gonna be made per some guideline, right, for some ASTM, right, with the
So
open
the
area.
air actually.
Right, exactly. This is also some kind of key stuff here. Light frame wood backup wall, is it recommended for adhered masonry veneer? So this is again from Latticrete, so this is kind of funny. They're saying that, because of volumetric swelling and subsequent shrinkage, kind of the in and out and all that happens with wood products, with most wood products, that can be an issue with adhered masonry veneer. Latticrete does not, they do note that certain wood-based products can be used with their product lines. So this excerpt that I show is not a dead fast, 100% thing. But again, I bring it up because it's just something to consider when you're designing a building. Should I do a light frame, wood, and then have adhered masonry veneer on it? So the proof is in the pudding, like I said, like usually the manufacturers are more stringent than the other way around, than the building code, right? So this is the Latticrete system warranty for using their products for adhered masonry veneer. So if you want a 25-year system warranty, it has to be on a CMU backup or a concrete backup. If you want a 15-year, you can do your steel, your light gauge steel, or wood frame backup. So that is proof really of what I just said, so so clearly industry best practices suggest the CMU or concrete backup wall. So take that for what it's worth. And again, in qualified installers, we also, IMI has an adhered veneer certificate that we offer to the journeyman masons and tile setters out there. So again, also just one last thing, a lot of times adhered veneers are done by your kind of run-of-the-mill masons, I call it that. A lot of times it's done by the tile workers, right? The tile setters and tile contractors also do some of that work. So we have all of those people in the IUBAC as members. So they all can do this special training for adhered veneer. And I believe this is like a day and a half long, hands-on training. They get like an hour or two of, classroom. So right, training is both in class and hands-on. So again, this is for craft workers, not for architects or engineers. But we do have plenty of webinars on adhered veneers. And then I don't know how much time I have left, but I'll take
15 minutes.
Okay, good. We got enough time for some talk about green building benefits of natural stone. Is stone going to run out? Right? Indiana limestone says that it's not a supply problem. So this is a little excerpt from Indiana Limestone Institute. They're saying that the supply of Indiana limestone is probably good for at least another 500 to 600 years. Based on, a lot of assumptions, obviously, but so I think we're good, with that, because we have to, I think as well, I'm not a designer, but designers and people in the building industry, we have to think about, and that's kind of what we're talking about, sustainability. The way that we're building now, is that the way we're going to be able to do things in 10 years or in 20 years? Will a product be readily available 10 years from now? I read an article a year ago, we have a global shortage of sand now. I mean, who would have thought that we have a sand shortage, but apparently we do, or we did. So, you have to think of these things, but as far as limestone, I think we're okay. Matt, you want to say anything about the granite supply?
Yeah, granite is similar. It's measured so far out that it's hard to even imagine. 500 years.
Yeah.
So if you compare it to crushed stone activities, it's so small amount of removal near the dimensions still.
Sure. Okay, right. All right, that's a good point. So as far as embodied carbon, I know that's a big topic, obviously, in the last couple of years or more, but certainly getting it's kind of a forefront issue. This here is from Make Architects. Some of you may have seen this graphic somewhere, but this, again, granite will be similar, but this is, talking about limestone, 2-inch limestone. We're just looking at embodied carbon based on square meter, right? So limestone is actually the least embodied carbon out of these, what's listed here at the top row. So we have brick at 40, which is still actually not bad. Anodized aluminum is, you're not going to have a whole building facade in anodized aluminum, I don't think, but that it's all obviously a lot of the rail systems and trim systems. What do you say?
I've got it.
What do you say?
I've got it.
Okay, yeah, all right, there you go. It's quite a bit. Precast concrete is, has a lot of embodied carbon to create precast concrete panels. I was sort of surprised at, ceramic tile being, up there at 90. I think ceramic tile has other benefits, but certainly a lot more embodied carbon. It's manufactured, fired, yeah.
I should know this, but I don't. A1 to A3, is that extraction, refining, processing, fabricating? What is A1 to A3?
A3, yeah, to say A3, yeah, so this is gonna be cradle to gate, I believe, correct, right?
I'm pretty sure.
Yeah, cradle to gate, so raw materials, manufacturing, and then basically getting it ready to go out the door, basically, not the actual travel to the job site or wherever.
Or the installation.
Right.
Or the installation.
We're comparing, for example, limestone to GFRC.
Yeah.
We're including the quarrying.
Oh, yes,
extraction,
all of
refining,
that.
Processing of those.
It's basically the
materials.
manufacturing.
Yeah.
Right, yes, but not
Also
including,
extraction.
yeah, extraction, not including shipping.
Right.
So, okay, we know stone is heavy, so we do know that, right? So, but this is interesting, again, glass, a double glazed, double pane glass is 95, per square meter. It's pretty significant. And so if you're doing triple pane glass, which we're all doing now, apparently, that's another concern. Another way of looking at it is, again, this is from the Architecture 2030 website, embodied energy, same kind of thing, but just looking at it by weight or by volume. So again, I just put the arrow at stone. It's way up the list there on, pretty minimal embodied energy. You have aluminum, steel, you have glass, again, just some thoughts. Brick is sort of in the middle here. Just, other things to consider, which I think that we are gonna start considering these things. If we're not considering them now, I think that maybe we're gonna be coerced or, forced somehow to be looking at these things as the new amendments come up in the States. I think that in a couple of countries in Europe, they're already looking at, like in England and I think in Netherlands, they're already embodied carbon is sort of part of their code now. I think they have to do an analysis and include this when they're doing their permitting applications, I believe. But
I know, and for good reason, that you excluded transportation, but.
right.
It does come up a lot.
Yes.
Because for instance, like, let's say we're talking about slate, right? You can get slate from Spain.
Yeah.
Very easy to access.
Yeah.
You know how much you can get, how easily you can get and all that, right?
Right.
You could also get slate from Vermont.
Right.
But you've got all this overburden, all these geologic complexities, and you don't necessarily know how much you're gonna get out of
Yeah.
the yield, out of the quarry.
Sure.
So now there's this conversation about, oh, we can get this stuff locally.
Right.
Yes.
Yeah.
Yes, you can.
Yeah.
But it's not necessarily the better choice, right?
Correct.
Because by the time you get something from abroad, it's this conversation about accessibility, availability, economics, whatever. And so I think that the transportation is a complex.
It is.
part of the equation.
And notice how in that other chart, they didn't talk about that.
Yeah.
It's, and they do it for a reason, because again, they don't know if jobs going to, California or going to be down in Boston. So it's hard to really, but yeah, on a project,
Sometimes it works in your favor and sometimes
Yes.
it doesn't. But
right. And this is the last couple of things I want to talk about is thermal mass, basically, and then a couple of websites for you that you can have. Other benefits of masonry and, stone, including with that are some thermal mass benefits. ASHRAE publishes several building specific guides like this one, advanced energy design guides for K through 12 schools. And they note that thermal mass is one characteristic to take advantage of. And we're not going to read all that text. That's a horrible PowerPoint slide. But, I think that we know what it means, thermal mass. It essentially reduces the peak conditioning demand of the space. I'm not an HVAC tech. I'm just saying that is something to look at. And ASHRAE does give you opportunities. Actually, I think I have that. Actually, I don't have that in this slide. On when you look at U values of a wall that's required, if you have a mass wall, you're actually allowed slightly less insulation for that wall assembly. So, again, ASHRAE is noting that and kind of giving you credit for the mass wall in certain cases. And what I wanted to show on this is kind of cool. Most people think of mass wall, the thermal mass benefit is only if it's, on the inside, like a CMU backup wall. But actually, it actually can help you even if it's a facade or a brick veneer or whatever. This here was done, this is from 2021. So this is looking at heat flux, dynamic energy transfer versus time. And they're just looking at a steel stud is just this solid blue line. And then you put forget insulation, because there's too many lines here. Brick veneer over steel stud is, you can see that dampening and the lag a little bit. Just with using a brick veneer, on one side, no insulation, nothing. So thermal mass, yes, it's better if it's the back of wall or whatever, but that brick veneer itself does actually, can help you.
Is that assuming that you have a ventilated airspace where air can come in at the bottom and exit at the top?
Yes,
In that graph, it's showing that.
I believe so. I'll have to, I didn't do
Because
the report.
I've actually tried to find this kind of information for a while in terms of like all things being equal.
Right,
Let's say you replace a 080 aluminum skin ventilated rain
Right.
screen with something with thermal mass, right?
Yeah.
Intuitively, I would think that a thermal mass, outboard of the rain screen, outboard of the insulated,
Right.
AV envelope
right,
is still going to temper that swing
Right.
over time.
yes,
But most people discount that.
correct. That's why I wanted to at least show this. So I'll give you the slide after. So this Canadian, the Canadian Masonry Symposium, that was a hoot. You should have been there. So, so we can give you that paper actually. Building a facade to last, this is kind of what the symposium is about, right? Is, when we talk about durability, and it's more than just durability, but, I think everyone is very familiar with Carbon Leadership Forum. How long does the wall last? How long does a facade last? Well, according to the CLF, stone and brick, stone lasts 50 years. That's the service life of stone. Stone will last much longer than 50 years, but whatever, they're calling it 50 years. Precast concrete panels, 30 years, metal and glass curtain walls, 30 years. So there is something to this as far as building for longevity, right? As far as adjustability and adaptability, that's a different conversation, which, stone does, so stone masonry does need to be maintained, right? I mean, there's the maintenance, not an issue, but I mean, I think most products need some kind of maintenance. I always, any product that says there's no maintenance, I question that. And just a few, not gonna get into this, we only have a couple minutes. Anyone who wants me to look at any project, give me a call. What do you want me to look at? You want me to look at the specs? You want me to look at the movement joints? Just let me know. And, we do that. There's no cost for that. When we look at things, we're looking at it based on, function, constructability, cost, and aesthetics. Sometimes for some owners and for some projects, cost is not a big factor, but on most projects, cost is, somewhat of a factor, right? But how important is it? And aesthetics is that's kind of the last thing because it's very subjective, right? I might think it looks good and you don't think it looks good. So, that's why aesthetics aren't in the code, right? Because, and again, as an architect, it's your building and your design. A few resources, imiweb.org, obviously, naturalstoneinstitute.org. I talked about them a little bit, but you can, go to that. Very good website, a lot of free downloads there. You don't have to be a member, okay? And then that Indiana Limestone Institute, that is their website as well. And there it is. There's another version, the 22nd edition. I think I have like the 10th edition over there. So the IMI won't buy me a new copy. So, but
Which edition was the vintage year?
limestone hasn't changed much in the last 10, 12 years or, 1200 years. So it's all right. Summary, natural stone veneer is attractive. I think it's durable facade option for many buildings. New buildings also. Adhered stone veneer is best at less than 30-foot high, and QA measures and QC measures are important. Mechanical attachments vary a lot, and it's just tough to really get into that a lot in this presentation based on the thickness, the size, the panel shape, or the panel size, shape, type of stone, etc. And stone is a green building material, but yes, it is heavy, and you have to transport it, somewhere. But if you're working with a fairly local quarry and a fairly local fabricator, and you're in Boston or whatever, that's not bad. So I was just down at the quarry in Connecticut, right, in New Branford, Stony Creek, right? They're a granite quarry there, and so I was there. Get your granite there. You can bring them down to Rhode Island to structural stone, and then you're in Boston. It's all within 100 miles, right? So it's not too bad. And that's it for me. So I appreciate it. I'll stick around for a while. And any thoughts or questions? Thanks. Now I'll have the site. Anyone online? Yeah, or you, Stephen?
So I feel like every day the same request I keep getting is some version of, I want a stone facade and I want so much freaking insulation in it and I want the perfect thermally broken anchors.
Right.
If I ask you what's like the most insulated ISR value wall you can get me with a natural stone facade, and where do your thoughts go towards immediately?
Well, then you're gonna have some kind of, you know, a rain screen type system, I think, and you're gonna have. So again, you're gonna deal with NFPA 285 and things like that as well in most buildings or a lot of buildings, I think. Whether you use, what we see a lot with masonry and, you know, stone being part of masonry, we see a lot of mineral wool, you know, right? You know, so the, I don't wanna say it's a problem, but I mean, the problem is that we end up getting, I've seen it now, sorry, you know, 6 inches of mineral wool, right behind, I mean, it's getting, this cavity is getting, this wall width is getting crazy, I think. I think it would be, we love mineral wool has a lot of benefits. I think if we're doing an open joint cladding system, I think mineral wool is good because, you know, water doesn't really affect it, it drains and all that, so I think that's better. But if it's, if there's mortar joints or if there's soft joints, where you're actually closing it off, and hopefully not too much water will be getting back there. I don't know, I mean, I think if you're worried about this huge wall, you know, I think, you know, with our values and things like that, maybe look at a different type of insulation material. Again, I'm not anti-mineral wool, but there's a lot of other options there that if it'll pass 285, right? But then as far as all these different systems with these split tail anchors and all that, all of them have now the thermal isolators and things like that, you know, pads and things like that to try to reduce thermal bridging, right? So, I mean, there's ways of doing it. You have anything to add to that? There's ways of doing things.
Yeah, we've been using mineral wool and
Yeah.
the project that I mentioned for with the marble, we use thermally broken, back-to-back sort of angles, and we have 5 inches in our wall.
Okay, yeah,
And then we have the initial 5/8 of air cavity. and
Sure.
2 inches marble.
okay,
But the angles were, I think they were 1/4 inch aluminum, so. In order to cantilever out and to pick up.
1/4 inch aluminum, right,
Yeah.
yeah, that's
And
pretty
they were
hefty.
hatch channels sort of like made into like thermally broken. Channel to channel sort of to be able to extend that out to pick up the stuff. Because we did have issue at some point, they didn't engineer it properly because they were looking at only the strength of the angle, but not looking at deflection of
Right,
the angle. And then at the mock-up, they had the stone sagging.
there you go, well, it's good that it was on the mark.
Yeah,
Sure.
exactly. So we had to and then they had to rework it and go back to what the design originally, it's like a 1/4 inch sort
Sure.
of channel to channel to structure work.
Yes.
Further, you get like the cantilever.
The cantilever action
Yeah.
is, that's
We have
insane,
3 inches.
plus the air cap.
Plus the
Right,
air cap.
yes,
So
sir,
as much as I'd love to see CMU back up on everything.
yeah,
Like your, CMU does have a lower pull-out strength than, 16 gauge metal stud, let's say.
Mhm.
I know 16 gauge is heavy, but if we're talking about
Yeah.
something heavy, my point is that you could easily accommodate 8 inches of mineral wool. And then have your rail outboard that be whatever depth it needs to be to support a
sure,
relatively lightweight
Gotcha.
natural stone platter.
right,
So in terms of what our value can you get? I would say, 8 inches of mineral wool account for the thermal bridging through your,
yeah,
24 on the center square
Yeah.
space in the NFPA, right?
Yeah.
And those numbers are readily available. But it's definitely, doable. I would say once you get past 8 inches of mineral wool, like,
yeah.
but if that's a pretty solid R value.
Yeah. And one last thing, and I know we're gonna wrap it up soon, but last thing, little pitch on, talk about weight, right? So the weight is a factor, especially when we're getting crazy, not crazy, but we're getting way out there with cantilever and stuff. So with, yes, stone is heavy, we know this, but so there is, I don't know if you've dealt with it much, you probably haven't where you are, but honeycomb back thin stone panels, right? Thin stone veneer panels. So there are a few manufacturers out there. So it's a natural product, but then it's adhered to a aluminum honeycomb. So you get like 3/4 of an inch of aluminum in a honeycomb type of fabrication adhered to a 1/4 inch of stone. And so that is obviously much lighter than 1.5 inches of granite. And so in some cases, there's a manufacturer right here in Wilmington, Mass. that does that. That's what they do. Yes, so, it's a, you know, I did a whole presentation on this last year, yeah, so anyways, that is out there as a, you know, something to think about, maybe on a wide wall, maybe.
I'm working on a project.
You can do glass laminate with thin stone, but that also has its own issue, delamination and
Yeah.
the going and all that. They've recently done a project in New York Financial District, when it was completed, it was amazing, just, I think, last year or two. I haven't seen it since, but it looks beautiful. Back, Corsa did that, but they went out of business, so they have to replace it kind of like remove some just.
So I'm actually working on a project right now where the only reason that stone on honeycomb came up was because there were absolutely zero bids for the full bed masonry basis design.
Oh, interesting,
Nobody bid the job.
okay,
So
Huh.
there's that.
well, all right, well, we don't love to hear that, or, yeah, I don't love to hear that.
It's secondary market, so when you
Okay.
get out of the big cities.
Right, yeah,
and you
sure.
have a unusually large job,
Right,
that's when you.
less people are aware of it and chasing it, and
And also, you know, even if they were to go after it, they'd have to put up, you know, dozens of people in a hotel.
Yes, correct.
So, right.
fair enough. Any other comments or questions? You want any chat stuff?
No one in the chat, anyone online?
Thanks, guys.
Great, thanks.
All right. Thank you.